Hello, everyone. My name is Chander Dhall, and I'm the CEO of Cazton, an elite AI consulting firm delivering high-impact, enterprise-grade solutions, including custom-built AI chatbots and advanced automation systems tailored to complex business needs. Today, we're going to talk about one of the most important concepts, which is agent memory. And by the way, it's the same for your chatbots. And why is agent memory so important and how to get it done right? So today I'm going to show you 4 strategies, starting from a strategy in which we talk directly to LLMs. And let's not forget, LLMs are stateless and they do not have any memory whatsoever. And then we'll use the other 3 strategies, sliding window, hierarchical, and entity graph. And one of them will lead to the highest precision, and that will be the high precision or recall winner. However, that doesn't always mean that it's going to be 100% recall with that particular strategy. We'll show you different use cases, and from that, you can decide what's the best for your particular use case. We will start with 60 seed messages. And the reason we chose 60 seed messages is we saw that in a lot of companies, when they do AI testing, especially on their chatbots, a lot of times they go up to 10 to 15 conversations only. And guess what? All the 3 strategies provide 100% recall up to 30 turns in most cases. And that's why by the time you end up in production, you may not even know that you have less than 100% recall. And that's a big no-no. We also will show you 10 recall questions. And the first 5 questions are really easy. And all the 3 strategies get them right. However, the next 6 questions are more nuanced. And that shows how you need to change your testing strategies, especially if you're leaning more towards the easier questions during your AI POCs. So let's have some fun and define the problem. If you started working like me before ChatGPT was launched on AI applications, you may have noticed the context limit's really small. The token window limit would be the most important thing before you even started creating these applications. You would notice right up front that these LLMs actually are stateless. So after ChatGPT was launched, a lot of people assumed that LLMs are actually stateful. And in some cases, they even thought that it has a memory. A lot of that has to be done by engineers like you and I. You might have heard of the famous quote, I told you my name, my budget, my team, my deadlines, and you forgot everything. And that is why memory happens to be the most important conversation in enterprise applications worldwide. So now that we know that LLMs have this problem, that they are stateless, and every API call starts from scratch, how do we solve this problem? Well, very easy. We can send the full conversation history every single time. Yes, except we know all LLMs have a limit. All right, then maybe you can just summarize it. Let's try it out. In case you send the entire conversation, and let's assume that's within the limit an LLM expects, in that case, you're still having costs that are going to explode. You're also going to slow down the LLM. What if you start summarizing parts of it? In that case, you still have that issue that you may be losing some context, maybe some fact, anything real world that you really care about that got compressed, because all summarizations have a compression problem. And then finally, users will have to repeat themselves quite a bit. So why does memory matter? One of the most important things to remember is that more than 70% of enterprise projects will require multi-turn agents. And the number one gap cited by developers happens to be long-term context. And by the way, If you go with the LLM alone, which really has no memory, and you go with the best memory strategy we're going to compare today, you may be looking at a 20x token cost difference between these strategies. And that's why memory isn't just a feature checkbox, it's an architectural decision that determines cost, recall quality, and user experience. So the first strategy happens to be sliding window, which keeps your recent messages and then summarizes the messages before it. An analogy would be a security camera that keeps the last 8 hours of footage and then writes a one-page summary of everything before that. Now, it's really easy to implement, and that's a strength, and it's also going to have a low token cost. In this case, roughly 1,100 tokens, and it's great for short conversations, especially less than 30 turns. And this is something to keep in mind. Just because it's great for that particular use case does not mean it's going to be great for another use case where we actually require a real world fact, even the one that was 100 turns ago or 1,000 turns ago. In that particular case, recall is going to be lower. And in today's demo, it's got about a 60% recall. Let's not forget, it will have 100% recall if it is less than 30 turns. So remember, it isn't about the strategy, it's more about the use case. And based on that use case, we need to pick the strategy. Strategy 2, hierarchical memory. Think of this as 3 different tiers. The first tier being hot, for example, a company's knowledge management system will have your team's messages as your first tier. And that's part of your conversation, and you want to send them as it is, uncompressed. Number 2 is your weekly meeting notes. And let's call that tier 2, and kind of compressed summaries, because tier 2, not as important as tier 1. And then finally, the least used out of the 3, which could be your company wiki. And those are extracted facts in your long-term storage. So better recall than sliding window. And of course, it can do better than it, but not as good as something that will always present the right fact every single time. Because tier 3, as you can notice, it will miss on certain facts here or there. Finally, we got entity graph. And I love this analogy. It's like a detective's case board where you have all these different facts, and then you got linkages between them, right as every single card with connections between them. And that's entity graph. So what does it store? It stores all the entities, anything real world, a name, organization, anything real world. Any entity that is real world gets stored. Facts, these are key value pairs for that particular entity, and you can have any amount of these. And finally, embeddings. You may have heard of vectors, and vector databases got created simply because of these LLMs wanting to search, basically do semantic search on your data and get you that particular retrieval. Now, in this case, what I love about Cosmos DB is that you have the native vector search inside Azure Cosmos DB. And then finally, relationships, which are connections between entities. Now, why do you get 100% recall in this particular case? I mean, the reason is simple because we don't really have any compression. We're doing the vector search, we're getting those entities, and those entities have the facts, and we can get all of that back. So in this particular case, for this particular data set, we are able to get 100% recall, except we're also using average 1,660 tokens. That's pretty much 50% more than the first strategy, that's sliding window. And remember, that's cost. So that's another consideration. So even though I would say there are 4 approaches, you might have noticed I start with 0. Why is that? That's because I'm an engineer, and as engineers, we use arrays, and we start with 0. That's not the case. I really don't think it's an apples to apples comparison because LLMs really have no memory, no context of what you're trying to do unless you provide it. So for that reason, I don't think it's a good comparison, but I still want you to see that you may be able to get 92 tokens, but you got a 0% recall. However, the other 3 strategies, very important. As you can see, we go from 1,100 tokens all the way to 1,660. And in this particular scenario, you go from 60% recall to 100% recall at a 1.5 times the token limit. But here's what I love about Azure Cosmos DB. Same database, same SDK, same partition key, different recall guarantees, and I can use all these three strategies at the same exact time. So that leads me to why Azure Cosmos DB for agent memory. Well, that's because we are in Azure Cosmos DB conference. That's not the case. It's really because at the end of the day, all my data is in Azure Cosmos DB. And by the way, for someone like me who's been working on document DB, that was, I think, was 2016 onwards, I started working on it. And then it became Azure Cosmos DB. And I know we now have another document DB, which is a little different than that document DB that was there long back. My data and my client's data lives on Azure Cosmos DB. It used to be a big problem to now have another vector storage, a completely new database just for dealing with vectors. Well, no, not anymore. We can actually have that data, your embeddings, your vectors live right alongside your data. I don't actually need to have another native vector search database. The schema is flexible, and we talked about that. I love the session isolation. My partition key in this case happens to be session ID, so I have 0 cross-partition queries. And then finally, for this demo, I'm not worried about global scale at all because all we have is about 60 different messages. But once I go into production, I don't have to worry about global scale because now I can scale as much as Azure Cosmos DB would allow me, which is literally all over the world. And that's why Azure Cosmos DB. So let's talk about the benchmark where we have about 10 recall questions. We got the core questions, basic recall. Why do we have that? A lot of times what we noticed was all these POCs that people were doing had a bunch of the same kind of questions. And a lot of times those questions were created by AI itself. Well, but it was also 100% recall based on questions that probably don't understand how these strategies actually work. So what you'll notice is 100% recall for all three strategies for the core questions. We also notice that every single data set is different. We work in healthcare, manufacturing, finance, fintech, tech, pretty much name any major domain, and all these bigger corporations worldwide in those domains have very nuanced data. That's why I wanted to show you how much difference gets made in just 5 questions the moment you start asking nuanced questions on that particular data and how the misses happen. So for example, in this case, sliding window only gets 1 out of those 5 correct. So your recall happens to be only 20%. But if you have the right use case, sliding window could be at 100%. And that's why it gets confusing. Before we do the demo, I would like for you to ask yourself which strategy is going to remember a URL mentioned once 40 plus turns ago. And I hope you get the answer right. Let's dive into the demo. As you can see here, I've got 2 providers. Here's Azure OpenAI, and you can also click OpenAI. It'll work with both the keys. So if you have Azure OpenAI, assuming you have the same exact keys for whatever model you're trying to use. Here's 2 different demos. One is Cazton and another one is default. And remember, they're both fake data, so please feel free to use your own data. I'm not going to ask anything from the direct LLM because at the end of the day, we're not going to get any answers. Now we're going to compare the other 3 strategies, which is sliding window, hierarchical, and entity graph. On the right-hand side, it's just a way to see what the results are and what to expect. So let's ask the first question and see what it does. While it's answering the question, I just want to show you that all 3 of these are going to pass. So this is actually a really easy question, no problem whatsoever. All of these strategies will get you the same exact answer, which is Cazton offerings are consulting, training, and recruiting. Same exact answer, pretty quick. And you'll notice hierarchical was extremely fast, but entity graph is actually slower. Still gets you the same 3 answers. So now I'm going to skip the next 4 questions and go to number 6. The reason is because the next 4 questions, we're going to get the same result from all the strategies. So here's a result which says about us and contact us. All right. So let's go to round number 6 and open this. And you notice it's missing consulting. Let's go to hierarchical, run this round. It's got about us and it's got consulting, which is true. And that's exactly what we were expecting on the right-hand side. Here's your entity graph. It's got about us and it's got consulting. It's got both the answers correct. All right, so now let's go back to sliding window and we're going to go to number 7. And here we're going to open the round and see what we were expecting. All right, it's got about, it's got WebP, it's missing products, and it's also missing from our stored graph context, which is true. Let's go to hierarchical. And as you can see, it's got pretty much everything except it's still missing products and also missing from our stored graph context. Let's go to entity graph. And you may have noticed entity graph is actually slower. So that's another thing to keep in mind is what your use case is. So you've got actually everything. You got products, you've got the about Chander Dhall, you've got the WebP. It's actually perfect. And it also says from our stored graph context. That's pretty amazing. Let's go back to the 8th round. I'm going to pass because they all get the training URL. So it's the same exact answer for all 3 of them. And now let's just show one more. And let me go back to sliding window. Let's go to number 9th. Very quick. And it's got something. Let's see what it is. Okay, so it's actually missing presentations, which is true. Let's go to hierarchical. It's got presentations. So hierarchical's got all of those. And same with entity graph. And in the 10th round, it's a very nuanced round. All that is getting wrong is not the response. They have all the responses correct, both of them, except they're missing from our stored graph context. All right. So how many of you got that right? I hope it's all of you. So what you just saw was direct LLM has no prior context. We didn't do that part of the demo, but the idea is you're not going to get any response if the LLM does not have that data unless you fine tuned it to have that data. Whereas sliding window, the first 5 questions correct. The next 6, it only got 1 right, which is the 8th one, which we didn't run, but it was really easy and it was going to run. Now you've got hierarchical, which was 3 out of 10, which means in this case about 8 out of 10. So you notice what's happening. Even though it was 3 out of 5, sorry, not 3 out of 10, we had the first 5 really easy questions, and you may think you have an 80% recall where all you had was a 60% recall because 3 out of 5 were correct. An entity graph in all the cases was 10 out of 10. Now, one of the things I want you to remember is that if you had a sliding window, which never requires you to go beyond 30 turns, you would have 100% recall on sliding window. So it's really not the recall as much as it is the combination of your strategy, your use case, and your data done right. So here's your scorecard. If you remove the blue, which is the first 5 questions, sliding window is only 1 question. That's 20% recall. Hierarchical, 3 out of 5, that's 60% recall. In entity graph, 10 out of 10. So, and 5 out of 5 and 5 out of 5. So that's 100% recall. Cost versus recall, the trade-off is right here. And it's important because if your use case is literally less than 30 turns, you're better off going with sliding window because the cost is 1.5 times more in terms of entity graph. You're using the least amount of tokens. You're hoping you get the response also faster. So that's another cost to keep in mind is performance cost. Otherwise, if you really care about higher recall, well, in that particular scenario, entity graph would be a much better deal altogether. So an easy way to look at this would be sliding window for less than 30 turns, supports the chat, recent context, hierarchical, about 30 to 100 turns. And again, this is more, it'll depend on your data, but let's just say ballpark, that's what you're looking for, especially if you're using it for planning or consulting and you have to have some key facts. And then entity graph, for example, you have your CRM bot or something where every fact matters. Like you don't want a response with a financial number that's actually not correct, and it can also scale to way more than 100 terms, because at the end of the day, you're really getting the fact correctly. So again, you can start with one. You can also upgrade later. You can also do a hybrid, which is also not a bad idea. And in some cases, you can have a combination of, let's say, sliding window as well as entity graph. For 90% of your cases, you may have sliding window, especially for less than 30 turns. And then you can, go to entity graph whenever there's a premium use case behind it. So again, memory is a spectrum, and you need to choose by recall, not by hype. And you got to remember what's your use case and what your data is like. What we covered was the problem, which is LLMs are stateless, they have no memory. Then we really covered the baseline plus the next three strategies. And then the architecture, which was really easy, by the way. You must be wondering why 5 Cosmos containers. To remember, for entity graph, you will have different containers per entity graph. And that's not at all a bad idea. In this particular case, that's what we did that. You can do it in multiple different ways, but for that reason, we had more than just one container. And then you've got the live demo, which had 10 recall questions. Then you had the evidence, which was 100% recall in terms of entity graph. And then the decision, which isn't really about the recall numbers that we shared here, but a lot more than that. And we discussed every single of those. Now, just remember, this is not production data, and this is literally fake data, but this is also not production level code. However, it's a good POC if you want to run, and that's your barcode. If you click that barcode, it will take you to this blog post that explains the nuances, how the decisions were made, and it also explains to you the different parts of the code. I just want to show you this real quick. For your code to remember, here's your direct LLM. And if you're a .NET developer, you can look at the right-hand side of the code. And if you're a Python developer, you can look at the left-hand side of the code. Direct LLM, it's literally sending the system prompt and then creating the message chain and then making a call. It's very simple. That's how you've been making all your calls so far. Next is sliding window. And as you can see here, we have the summary for anything beyond 30 messages, and then just 30 messages where everything is uncompressed and is part of the context we're sending to the LLM. And as you can see here, the window size is 30, and this is your 1 hour, which is, we just chose that time to live, and that can change for whatever you're trying to do. And then you've got the hierarchical memory, and here is where all your tiers are. And as you can see, here's your tier 1 size, your tier 2 block, and the max tier. Same for both Python as well as .NET. And then you've got the entity graph. This is actually really easy to produce because your entities and your embeddings are living together. So one thing to remember is that this is exactly how we anyways code when we are doing programming, because we have the same exact objects. Now we just have a way to retrieve those objects and then make it part of your LLM answer by giving it the context which it needs to give you the response. And finally, here's your read path on entity graph. And this is just a small blog post that I prepared only for the demo. However, a lot more detailed blog post is right here. And if you want to do a more involved code walkthrough, you can click that link and it goes through a lot more than what I just shared. So let's not forget, here's the link to that. And I hope you take advantage of it. Let me know if you have any feedback for me. I had a blast and hope you have a blast coding and using this in your applications. Thank you for having me. Have a great day and a great rest of the conference.